Welcome and thank you for joining. In this lesson, we'll look into combinations of transformations. Recall that so far we've been introduced to parent functions, so the linear, quadratic, the square root, the reciprocal, and the exponential functions, which are basically in the form b to the power of x. We've discussed that in details. And we've also looked into the transformations of functions, and we started with translations of functions. Now remember that when we translate a function, we just move the location of it, so the shape of the graph doesn't change. We learned how to translate functions vertically, so we call this a vertical translation for short. Learn how to translate them horizontally, so horizontal translations. And next, we moved on to reflection. So we learned how to reflect functions over the x-axis. We said that in this case, the y values changed to opposite because they went to the other side of the x-axis. Reflection over the y-axis took the points on the graph of a function from one side of the y-axis to the other, keeping the same y value but changing the x to opposite. And lastly, we looked at the reflection over the line y equals x. We call this an inverse relation because the x and y will switch roles. Lastly, we looked at stretches of functions, and that was our last lesson. Then the stretches can be applied in the vertical direction, where we can expand the graph of a function, so make it taller, vertical expansion, or compress it by making it shorter. And the stretches can also be applied in the horizontal direction, where we can stretch or expand the functions in the horizontal direction, make them wider by making them wider, or we can compress in the horizontal direction, which makes the graphs of function look narrower. So for short, we use the following acronyms. So this is vertical translation, horizontal translation, vertical expansion, vertical compression, horizontal expansion, horizontal compressions, and then the reflections. For reflections, we will use the letter R. Now, in today's lesson, we are going to look into all the transformations applied all at once on the graph of a function. And for this, we have to follow a certain procedure, and we're going to start off with just that. So when we simplify algebraic expressions, which involve multiple operations such as addition, multiplication, subtraction, division, we follow a specific order which we are very familiar with. We call it BADMAS, which suggests that to simplify correctly, we need to simplify inside the brackets first and then apply the exponents, division, multiplication, addition, and subtraction are left for last. Now, simplifying algebraic expressions is a form of transformation because we are transforming the way an algebraic expression looks. Now, similarly, when we apply multiple transformations to the graph of a function, we are applying different operations to a function. Now, since addition and subtraction are last in the BADMAS order, when we apply these operations or when we transform the graphs of functions following these operations, then translations, which stem from either addition or subtraction, will be applied last in the list of transformations. Reflections, on the other hand, which are created by multiplying a function by a negative, will take priority and will be applied to a function before the translations. Now, multiplication of algebraic expressions matches the stretches in transformations of functions. So we're going to say that multiplying a function by coefficient a will cause a stretch in the vertical direction, and the stretch can be either an expansion or a compression. And x that is transformed or stretched by multiplying by a coefficient k will cause a stretch in the horizontal direction, so it can be expansion or compression. Now, stretches both expansions, and compressions are applied first in the sequence of transformations. There are no required order for horizontal versus vertical, so either or is fine, but preferably we will apply the vertical stretches first. It is more conventional because they're typically easier to apply, and we want to do the easy stuff first. Now, the order of transformations in graphs of functions will be compressions and expansions first, and then reflections and translations. So a good acronym to use is CERT or CERT. Now remember that compressions and expansions stem from both multiplications of functions with either a or multiplication of x variable by k. So they're both multiplications. So they both have the same order in a way, but we list the compressions first because it's easier to remember the acronym. CERT is easier than saying, let's say, for example, ECRT, right? So we are going to take a look at how each and every variable will help transform the function. So in what way? So we're going to start off with a general equation. So if y equals f of x is the equation of a parent function, then the parent will be transformed based on the following coefficients. So we can multiply the function by a coefficient a. We can multiply the x by a coefficient k. Remember, these are connected, directly together. We can subtract a number from x that causes the horizontal translation, or we can add a number to the function itself, so to the y values or to f of x, and that's the vertical translation. So let's take a look at each and every coefficient one at a time. So first we'll look into the coefficient a. So for this, I have created a number line just to visualize or to create a picture in our head on how the coefficients or each coefficient will help transform the graph of a function. So pretend that this number line will represent the coefficient a, or the possible values of a. So if the values of a are greater than 1, then the function will undergo a vertical expansion. So in this case, a function, our parent y equals f of x, will transform to become y equals a times f of x, which means that the values of y are being multiplied by a number. So if this number happens to be bigger than 1, let's say number 2, number 3, number 100, number 1.1 even, then we're going to say the values of y will get bigger than what they originally were. So in this case, the function will undergo what we call a vertical expansion. Now, similarly, we're going to say that if the values of a are less than -1, the function will still undergo a vertical expansion, but along with it will undergo also a reflection over the x-axis. Because when the value of a is negative, it means that we are reflecting the y values, and the reflection of the y values happens when we take the y values to the other side of the x-axis, and that's why we call it reflection over x-axis. Now, when the values of a are between -1 and 1, and remember that we're not including the values of -1 and 1 because there are no stretches, but we're also not including the value of a equals 0 because a equals 0 will change the graph of any parent function to a constant function, and it changes the entire nature of the function itself, so a cannot be equal to 0. And we're going to say that if a is any number between -1 and 1, such as, for example, a equals 0.5, that means that the value of a 0.5 will cut the y values in half, making the graph look shorter, or make the graph compressed in the vertical direction. So we're going to say that this will cause a vertical compression. The same thing applies to the a values between 0 and -1. So the graph of the function will undergo a vertical compression. Now, it is preferred that for vertical expansion we use the word taller, and for vertical compression we use the word shorter. Now, next we're going to move on to the effect or the changes that are caused by the coefficient k, the changes in values of coefficient k. Now, remember that coefficient k will change any parent function of the form y equals f of x into y equals f of k times x. So as you can see, this time x is the variable that is directly transformed by the coefficient. Now, we're going to pretend that this number line represents the values of k. And we have investigated this in the previous lesson, so you can refresh your memory by going over that lesson again. But this is a summary, remember. If the values of k are greater than 1, then the function will undergo what we call a horizontal compression. And we try to compare this, let's say, for example, with someone that has, I don't know, extra fuel in its body, extra calories or extra energy. So this value of k, when greater than 1, will make the values of x bigger. So it will give the function extra energy. So therefore the function is going to reach the y values a lot faster, and that will cause a horizontal compression. So the same y values, for example, are reached for smaller values of x because the k is kind of empowering or speeding up the x values. And that's why the graph becomes narrower. Now, if values of k are less than -1, same thing is going to happen. There will be a horizontal compression, but along with it, the function will undergo a reflection. Now, the reflection is caused by the negative sign only, and the reflection will happen over the, let's take a look at this. Remember, the x values are changing to become negative, so they go from one side of the y-axis to the other. So since the x values are changing, that will be a reflection over the y-axis. Remember, we said either reflection over the y-axis or reflection of x variables. Now, if the values of k are between -1 and 1, such as, for example, 0.5, 0.1, 1/10, 1/100, -1/100. So any number between -1 and 1, again, excluding 0 and excluding -1 and 1, because -1 and 1 won't cause any stretches, and 0 will make the function changing to a different or belong to a different group. So we're going to say that the function will undergo a horizontal expansion. And the reason why, again, is because a k value less than 1, let's say 1/2, will decrease the x value. So will decrease the energy of your body to reach, a specific distance or target. So it will, the graph or the function is going to need bigger x values because they are cut by this coefficient. They are diminished or smaller, becoming smaller by this coefficient, and that's why we need more x values to reach the same y value. So if this is square root of x, we're going to need more x values to reach the same y. Now, next we have the vertical translation. So the vertical translations are described by the coefficient c. So the coefficient c is the last number that we add in the equation. So it's usually a number that is standing by itself, and it is added to this part of the function, which is basically the y value of the function with these transformations, and we add a number c. So because the c values are added to y, then we're going to say that when the c values are bigger than 0, the graph will move vertically because the y values are increased by a positive number. So vertical translation up. And if the c values are less than 0, then the function will undergo a vertical translation down. So the y values will move further into the negatives. Next, we have the coefficient d. The coefficient d is a number that is subtracted directly from x. And that means that the x values are being shifted or translated. So if we were to visualize the translations in the horizontal direction by using a number line, so this number line represents the values of d, then we're going to say that if the d values are positive, the horizontal translation will happen in the positive direction or to the right. And if the d values are negative, then the horizontal translation will happen in the negative direction or to the left. Now be very careful because in this case, a function y equals f of x, the parent function, is moving or is changing to become y equals f of x minus the value of d. So when the value of d happens to be a positive number, let's say if d equals positive 3, then the transform function would look like x minus a positive 3. So you will see a minus inside the brackets. Now, if the value of d happens to be a negative number, and I'm choosing negative 4 in this case, then y would be equal to f of x minus, and then negative 4. And that will make the function look like x plus 4. But remember that the plus sign indicates that the value of d was a negative, right? So the plus comes from the two minuses together. So whenever we see a plus, it means that the graph has moved in the negative direction, okay? And I'm just going to add in here the vertical translation. So just to make this more complete, so in vertical translations, we have the parent function y equals f of x changed to become y equals f of x, and we add the number c at the end. So we see that the number is added to the y values. Now lastly, we had the reflections, which we kind of mentioned in here. So reflections can happen over the x-axis, and when that happens, the parent function y equals f of x is changed to become, remember, reflection over the x-axis will take the y values to the other side of the x-axis, so it will change the y values. That's why we have negative f of x. And reflection over the y-axis is going to take the numbers to the other side of the y-axis, keeping the same y value, but changing the x to opposite. So we're going to say that this will make the function change to become y equals f of, this time, negative x. Okay? And this is how, in general, we think about the coefficients in a transformed function. Now, next, we're going to take a look at some examples on how we translate or how we transform functions in general. Thank you for learning with me, and bye for now.